my presentation will focus on a recent experience of exchanging data, integrating data to BIM and exchanging data for building performance simulation. I would like to start with the goals and objectives of EU for boosting the use of BIM. So first of all, we have the Green Deal and sustainability objectives of EU, which is something that we all know very well that BIM can accelerate processes for energy performance simulation, especially for new constructions, and also help us manage the waste through schedules and other features. It aligns well with the objective for a single digital market, like the IFC, specific formats, and also framework. Above all, it enhances collaboration by providing standardization using the different frameworks, boosting efficiency in the public and private construction by bridging different gaps, avoiding silos, and of course supporting modern construction techniques, even also financing mechanisms like the BIP project proposed, and of course ease public procurement procedures. It also helps with compliance with EU directives, especially the Energy Performance Directive, environmental regulations, and of course data management, if I consider the previous presentation early this morning. It also, in the research field, it has a great prospect by integrating emerging technology like information, Internet of Things, AI, big data, digital twins, like Giorgos Artopoulos said in early presentations, and cross-border collaboration by allowing remote connection by experts, exchanging knowledge and understandings. Now, observing and looking at BIM from the perspective of the AEC industry and offices, the number one key that most of the offices stare at is the possibility for improved collaboration. And one key aspect that is blocking it in the field of energy is interoperability. They value a lot the reduced of cost, and there are recent metrics by researching the market that they can save 7 to 12% of their cost and expand their acceleration. It also brings new services for the firms like lifecycle management, maintenance, understanding that building is dynamic, so there is a service for the building after its construction, and of course the energy efficiency, which is one of the big objectives of the EU, by helping firms work on early design decision making in terms of the rehabilitation scenario or the energy upgrade in case of existing, or design the mind towards the energy performance of such buildings. So in new constructions, BIM can provide early stage analysis using massing tools. It can help with thermal zoning. It can also help on energy use analysis by estimating the building's energy use per unit area. Solar shading analysis by finding the surface that is hit by radiation, so helping with the conceptual design, calculation of heating and cooling loads, and of course all of these can be used using the parametric associated design logic that BIM inherently provides, may help adjust the architectural parameters like orientation, number, size of transparent envelope, building morphology, trees and green location. In existing buildings, things become more complex because we do have the analytical documentation phase. All the previous presentations mentioned the complexity of this approach. So we need to scan the building and, of course, do the environmental monitoring. Once the steps are performed, then we need to find a way to integrate this data to BIM if we are looking for a dynamic energy performance simulation. And then we have the last piece for getting the results, working on design optimization, or post-occupancy management of the building. Of course, if we look on heritage buildings, we all know that things become more complex because we have limited and unreliable data on building materials. We have air leaks, so we don't necessarily have airtight spaces. We are seized by regulatory and conservation requirements. We do have complex geometry and different structural systems, electrical components, a lot of ornaments in the exterior envelope of the building, thermal bridging because of inconsistency compared to contemporary buildings of the material layers, lack of standardized simulations of all this. Also, we need a lot of customization and calibration needs of the different properties that we need to accumulate to integrate to a BIM software. Of course, preserving aesthetics, integrity, and limitations also like res integration to heritage buildings, and so on. This can become much longer. As I said at the beginning of the presentation, I will give an example here that this is a pilot building from our involvement in BIP project. It's the Old British Cavalry Club located in the cross-border near to the buffer zone of Nicosia in Cyprus. It was also in a ruined condition, so it even increased more of these complexities. We started here with scan-to BIM with terrestrial scanning to first get the geometry, try to be as precise as possible, and of course it followed up by different indoor environmental monitoring, outdoor environmental monitoring for 1 year in order to get all necessary data to further proceed with finding out how the integration process will proceed. One of the biggest mistakes that we did is first we thought about the BIM software that we use, which was like number one that came to our mind. And then we said, okay, we're familiar with specific energy simulation software. So which way do we bridge this information? The only possible way is GPXML, which these were a kind of a wrong approach because of the different requirements and the different logic that the energy simulation software have. Therefore, our advice is first start with the simulation software and the method to be used, then find out which of the exchange schema between the two is accessible and provided to the software, and then set up a strategy with the BIM software that one can use. Then, number one key after that is to have a list of the requirements for the dynamic simulation as a checklist, and that's also what we did, so that we keep track of every data necessary. This is the final BIM model that we constructed, and now we headed toward this journey of making the BIM model into a building performance simulation model. BIM softwares are 3D detailed model, and in our case, the building performance simulation software needed a planar surface 3-dimensional model. So the challenge here was to translate this into planar. So usually the different BIM software have their own conversion mechanism from 3D to 2D. In the case of Revit, it has the feature of spaces and rooms that automatically scans the wall center line, finds room boundaries, and try to create a manifold for to be input later on into the software. But this is the results of our trials. So as you can see, there are many errors because of the complexity of the structure, because of all these different combination of material forms. So we started making a loop evaluation and figuring out how to solve this issue. One of the biggest issues that we faced was the transparent envelope. So here are 3 examples of heritage doors that one can find, which includes the transom window on top, which this part only belongs to transparent envelope. And there are cases with doors that actually work as windows because they are totally transparent. Therefore, by using standard BIM ontologies or BIM families to exchange this information, it's not working. In order to make it work, then, for example, this part here should be designed and modeled as a separate family instead of having it all as one. So our understanding of this exchange is that good practices, guidelines, and practical solutions are needed in the case of built heritage. So we provided some here pointing towards object simplification. It needs a great collaboration between BIM and building performance simulation engineers, so the assumptions for the simplifications are validated and confirmed by the energy engineer. Also, ornamental and complex objects contained in heritage BIM can be excluded from the export, and one main strategy that may help this approach is to make a duplicate, a replica of a BIM model that will undergo all this simplification and exclusion of elements before proceeding to the exchange, in order to not affect all the other BIM users that architects will be using it for. We published already 2 papers containing detailed geometrical practices for geometry exchange. And I'm going to move on to the second part because the interoperability process is twofold. It's about geometry and, of course, data. So the second part for data, what we try to do during the integration is to add space properties like the different schedules for HVAC or occupancy schedules, and of course thermal properties of the material to the BIM model. As I said, we were using Revit. We make the first loop with GBXML to solve geometry, and during this first step, we also evaluated what kind of data we were able to pass to design builder. Then we mapped the missing data, and we found this alternative route. Design builder has this capability of retrieving data from CSV, an interactive table file. So once we loaded the export, we checked which ones were missing, and using Dynamo, we traced those information from BIM, and through this CSV auxiliary exchange process, we try to receive the data. It's something that someone can create for regular use and can help kill this process. Also, the thermal properties of the materials, we found out that the Revit file has this construction XML file in its directory, which someone can easily add these numbers and like conductivity, density, specific heat information of the material used directly to the BIM model. So in the case of data, we found ways to include material thermal properties for windows. Dynamo code was developed in order to bridge the gap between the missing data, and of course we noted the different metadata limitations, like for example, Revit lacked the ability to provide a full spectrum of the hours that someone could create a precise lighting schedule or occupancy schedule. And of course, GBXML had some issues storing this information. Here is a table that sums up all the process of exchange from all the different steps of the environmental analysis that are needed to any pre-processing of data necessary, and the extra effort that is needed in order to make the integration, and what are the limitations there. Also in this diagram, we show exactly the pathway towards integrating data and creating an interoperability workflow. This is, maybe I can skip this because this is just the benefits for solving the interoperability at the end of the day. So I'm moving directly to conclusions. Just to mention again that the most important part is a good collaboration between the BIM modeler and the building performance simulation engineer, so that all assumptions can be well defined. And further research should focus on better geometry optimization and enhanced BIM tools to improve data integration and transparent envelope design, which is key. Thank you.